Hi everyone, my name is Zhezhen Wang. In this video, I will talk about what I did to improve the performance of my regressor in this hackathon. So first, to improve the performance, the first major step I took was feature engineering. So instead of just feeding the raw data set into the model, I built a custom feature engineering transformation to extract more meaningful information from the variables. For example, I created a indicator variable from the PA's feature to flag whether a silence had ever been contacted before. Since PA's equal to -1, it presents never contact. I handle that carefully and replace it with a clear representation so the model could interpret it more effectively. Um, yeah, so I did it here. So for the next step, um, I've noticed that the balance variables was highly skewed, so I applied a log transformation to stabilize it. It helps many models to perform better because extreme values are no longer dominated the learning process. Another important improvement was handling time-relevant variables more intelligently. So instead of treat months and days as just numerical values, encoding them using sine and cosine transformations. This represents the natural of time, the circle of time. So, for example, if the December is understood by the model that is close to January, so this kind of transformation help tree-based models and the linear models um, capture the seasonal changes more accurately. Um, yep. Okay, so for the next step, I create a interaction features such as combining capturing sensitivity with previous context. So I also include a binary variables indicate whether the previous caption outcomes was a success or not. Um, these kind of domain driven uh, features often help models capture behavioral patterns that raw variables alone cannot detect it. Beyond the feature engineering, I focused heavily on the model selection and diversity. Instead of relying on just one model, I trained three different models. So the first one is logistic regression, pretty normal. Extra trees, and here's the gradient boosting. So the logistic regression provides a stabilized and well celebrated probabilities. Extra trees capture nonlinear relationships and interactions automatically, which works very well for structured Tableau data. Uh, Here's the gradient boosting is partially strong for this type of data set because it can model complex pattern effectively. So each model have their different strengths, so combine them allow me to capture both linear and nonlinear effects. To further, um, but let's look the code first. So these are the three models. Okay. Okay, so to further improve the performance, I use the fivefold cross-validation. This ensures that each photo maintains the same class distribution, which is especially important because the dataset is imbalanced. For each fold, I generated out-of-fold predictors and calculate the ROCAUC scores. After evaluating individual model performance, I blended the predictions using weighted averaging. So the tree-based models carried slightly more weight, while logistic regression helps stabilize the ensemble. The blend model archives more better scores than any single models alone, which shows the benefits of ensembling. Yep. So now, in order to improve the model fit, processing validation was my primary tool. Instead of relying on single train test split, I evaluate performance across multiple folders and monitoring both the average score and the standard deviation. A lower standard deviation across folders gave me confidence that the model was stable and no overly sensitive to specific data sets. Um, I was also very carefully to avoid data linkage, so all the pre-processing steps, like the encoding transformations, are all built into one pipeline. So this ensures that transformation are learned only from the training folders, uh, and there's no other small mistakes made because of the linkage. Finally, I consider the bias variance trade-off. Logistic regression helps control variance and it helps and keeps the model stable, while tree-based model reduce bias by capturing complex relationships. By blending them, achieves a better balance between flexibility and the generalization. The consistency between cross-validation score and the leaderboard performance further confirmed the model was not overfitting. So in summary, I improved performance through thoughtful feature engineering, device model selection, class imbalance handling, and weighted ensembling. So I accessed the and improved the model fitting using uh, statistic cross-validation, linkage prevention through pipelines, and the carefully monitoring of performance stability. Altogether, all of these structured allows me to build a strong and well-generalized model. Thank you.